10 structural failures every engineer must study. Welcome back to Blueprint to Reality, the channel where engineering failures become powerful lessons. Every structure tells a story. Some stories celebrate innovation. Others warn us what happens when engineering assumptions go wrong. Today's video covers 10 structural failures every engineer must study. Not to assign blame but to understand how engineering knowledge evolves. Introduction. Structural failures are not just historical events. They are engineering classrooms frozen in time. Each collapse reveals a missing calculation, a misunderstood force, a construction error, or a design assumption that didn't match reality. In this video, we'll explore 10 landmark failures and the critical lesson each one taught the world. 1. Tacoma Narrows Bridge, 1940. Wind is a dynamic force. The collapse of the Tacoma Narrows Bridge showed engineers that wind is not just a static load. What went wrong? Slender deck with poor aerodynamic shape, wind energy fed oscillations instead of damping them, or elastic flutter developed. Lesson learned. Aerodynamics and structural dynamics must be integrated into design. 2. Ronan Point Apartment Tower, 1968. Progressive collapse. A small gas explosion caused a massive partial collapse. What went wrong? Weak panel connections, no alternative load paths, local failure triggered global collapse. Lesson learned. Buildings must resist disproportionate collapse. 3. Hyatt Regency Walkway, 1981. Connections can fail. A simple design change doubled the load on a critical connection. What went wrong? Revised hanger rod detail, load path altered without full recalculation, connection failed under normal use. Lesson learned. Connections are just as critical as structural members. 4. Quebec Bridge, 1907. Ignoring warning signs. One of the deadliest bridge collapses in history. What went wrong? Underestimated dead load, increasing deflections, ignored construction continued despite alarms. Lesson learned. Engineering judgment must override schedule pressure. 5. Sleipner A Offshore Platform, 1991. Numerical modeling errors. Cutting-edge offshore structure failed during testing. What went wrong? Finite element model underestimated shear stresses, thin concrete walls failed explosively. Lesson learned. Computer models must be validated and checked critically. 6. Westgate Bridge, 1970. Construction stage failures. Collapse occurred before the bridge was completed. What went wrong? Improper handling of camber, mismatch, temporary conditions not analyzed, buckling during erection. Lesson learned. Construction stages are structural design stages. 7. Cantarell Oil Platform Fire, 1988. Cascading failure. Fire and explosion led to total structural loss. What went wrong? Poor safety system, structural elements not fire-protected, progressive collapse due to fire. Lesson learned. Structural design must consider accidental actions. 8. FAU Pedestrian Bridge, 2018. Cracks were warnings. A modern bridge collapsed during construction. What went wrong? Severe cracking, ignored load redistribution, misunderstood structure failed under self-weight. Lesson learned. Cracks communicate structural distress. Never ignore them. 9. Champlain Towers South, 2021. Long-term deterioration. A residential high-rise collapsed without warning. What went wrong? Corrosion of reinforcement, waterproofing failure delayed maintenance. Lesson learned. Durability is a structural design responsibility. 10. Versailles Wedding Hall, 2001. Overloading. A crowded celebration turned tragic. What went wrong? Roof not designed for added loads, unauthorized modifications, progressive collapse. Lesson learned. Structural capacity must never be exceeded. Why engineers must study failures. Each failure teaches something textbooks alone cannot. Real-world behavior, human factors, ethical responsibility, engineering humility. Failure analysis turns theory into wisdom. Conclusion. Engineering progress is built on lessons learned from failure. Every collapse listed here reshaped. Design code safety checks professional ethics. A great engineer doesn't just know how structures stand. They know why structures fall. If this video expanded your understanding of structural engineering, like, share, and subscribe to Blueprint to Reality. Comment below. Which failure should we analyze in full detail next? At Blueprint to Reality, we study failure so future structures can succeed. See you in the next video. Building construction triangular ruler.